We're going to finish up polars today. We're going to do 2 sections in just little exposure to some things. The most important thing today is we're going to talk about converting polar to rectangular and rectangular to polar. The most fun thing is 9.4. Okay. So 9.3 says we learned to graph in polar, right? You know what I'm talking about, the round graph paper? Okay, the fun graph paper. Today we're going to learn to do the coordinates back and forth between rectangular and polar. We're not going to do the equations because we don't have time in the year. So sad. Okay. So the idea, guys, is that if you are given, this look familiar to everybody? Unit circle, cosine, sine, right? So those were rectangular components. So if we know the polar components, so we're given an r and a theta, and we want to change that back into an x and a y, it's almost like we rotated a certain vector and knew the length of it. It's exactly like vectors, okay? To get back from polar into xy, okay, we're going to do r cosine of theta to get the x and r sine of theta to get the y. It's the same as we've been doing with vectors, okay? If we're given the x and the y, so if I knew this was the 0.72 and I wanted to find the r and the theta, pretend that goes through there. I don't even know what happened. Okay, so this is theta and this is r. How can we find r? We know we went over 7 and up 2. Pythagorean theorem. And how can we find theta if we know we went over 7 and up 2? Inverse tangent. We do, every time we do inverse tangent, though, our calculator is a little fuzzy on what quadrant we're in, right? So we got to be a little careful with that. All right, so it says find rectangular coordinates for this point, 3 pi over 4. Okay, do we all have our little yellow sheets? Because I would like us to do this in exact form. So when we write down the ordered pair should be 3 cosine of 3 pi over 4 and 3 sine of 3 pi over 4. Okay. We're going to look at our little unit circle, and you're going to tell me the cosine is negative square root of 2 over 2, and the sine is positive square root of 2 over 2. So this becomes negative 3 square root of 2 over 2 by positive 3 square root of 2 over 2. So we just changed from polar to rectangular, and this was one that could be exact values, okay? On the quiz, I will take either. What mode does your calculator need to be in? For this question, if you were to type this and give me a decimal equivalent of this, if you're going to put in the 3 pi over 4 as 3 pi over 4, you got to be in radians, right? If it's a free response question, I would tell you you could answer exactly or as decimals. I'm not going to be picky, okay? Because we're at the point in the year where I don't have time to be picky. But if it's a multiple choice question, you need to know how to use your unit circle to find exact values because it's likely it could be in exact values. Okay. So is this one we can do exact, guys? This is an r theta. Okay. So look at your unit circle. What's the sine and cosine at negative 60, or cosine and sine? 1/2, that one, right? Okay. So when I write 20 cosine of negative 60, it's actually 20 times 1/2, which would be 10. And if I did 20 sine of negative 60, it's actually 20 times negative square root of 3 over 2, which is negative 10 square roots of 3. The 20 and the 2 reduced. Are we good? I think this is on your sheet, yes? Some of you are. All right. Does it work when we do this? Let's think about this. Let's type it, or let's do it the way we want, and then let's see if it makes sense, okay? We want to say r cosine of theta, r sine of theta, right? We don't want to have to mess with the fact that this means back up. Well, let's see what happens. Cosine of 5 pi over 6 is negative square root of 3 over 2, so we multiplied it by that negative 1 out front. We'd get positive square root of 3 over 2. Everybody good? Over here, 5 pi over 6, the sine is 1/2, right? So we'd get negative 1/2. Okay, let's go back to the original question. 5 pi over 6 is around to here, right guys? But back up 1 means it should be over here. Does this point make sense for going square root of 3 over 2 and down 1/2? Are the signs right? Yes, yes, they are. So the r cosine theta and r sine theta works no matter which kind of polar it was. If they gave us a polar that was positive, negative, negative, positive, negative, negative, okay, it'll work. Oh, 2 more of these? Okay. 6, what's the cosine at negative 135? Negative root 2 over 2, and the sine is the same, isn't it? So what's that going to reduce to? Negative 3 roots of 2, negative 3 roots of 2. Okay. What if I said you could do it in decimal? You want to do one in decimal? Okay. Put your calculator in what? Radian mode. And just type 3 cosine of pi over 3, 3 sine of pi over 3. Okay. In exact mode, this is 3/2 and 3 square roots of 3 over 2. But on the calculator, you will get the decimal equivalent of those, so it should come out 1.5. I'm thinking, yes. Yeah. Mode, radians, good. And it was 3 cosine pi over 3, 1.5. 3 sine pi over 3 is 2.1, which is 3 square roots of 3 divided by 2. Oh my goodness, it is. Okay. So you could have given me the decimals. I don't care if it's free response. All right. Recall, oh, we already know all this, right? That sometimes it gives us the wrong quadrant. We're just too smart for that. Okay. So this says give 2. Oh my goodness. Find 2 rectangular coordinates for 5, negative 9. Okay, I'm going to start by thinking about where that is. Over 5, down 9. Okay, so how can I find the distance out to there? Pythagorean theorem, that's the r. Uh, 25 and 81 is 106, square root of 106. Okay, or about 10.3. Okay. So the other thing we need is some kind of an angle. In this quadrant, how would we find that angle? And they do these in radians, so it's going to feel kind of weird when you see the answer. Inverse tangent of what? y over x. Anybody awake out there? Inverse tangent negative 9 over 5 is negative 1.06, which, just to make you feel better, is negative 61 degrees roughly, okay? Does that feel like it could be in the right spot? Okay. So one name for this is that the radius was 10.3 and that theta was negative 1.06. Would you have known that was an r theta if I didn't tell you it was an r theta? No, right? It looks like, so they have to tell you because this looks like an ordered pair. There's no pi or degree sign. All right. They want us to come up with a second name for that. Okay. Remember a second ago I said it was like negative 60 degrees? Remember, find another name for that. Across from it, you do what? Across from it, you would add 180. But if we're in radians, we need to add what instead of 180? Pi. So if we added pi to negative 1.06 or whatever decimal approximation that was, this one plus pi, we get 2.08. Did anybody get that? Okay. But if we did that, what else do we have to do? If we were down here and we wanted another name for it that was around here, we would then have to make the radius be what? Negative, yeah. Instead of going negative 60, if we had gone 120, we would have had to back up that much, 10 point whatever. So it would be negative 10.3, comma 2.08. I do not make you do 2 on the quiz, okay? 1 and I'm happy. All right. And this one is actually easier because we should be able to do this one in our head. This would be nice if I gave you one like this. 2, negative 2. You should be able to tell me all about that point right now. What's this radius? 2 square roots of 2. Okay. But yes, you could do 2 squared plus negative 2 squared is 8. And then you got to square root it, which is square root of 4 times square root of 2. What is that? Doesn't look like a 4 to me. Okay. 2 square roots of 2. Some of you knew your special right triangles, though, right? Okay. Can the radius ever be negative? When we do Pythagorean theorem, it's always going to give us a positive number, right? If we decide to change because of polars to a negative, that's another story. What's that angle, though? Can you give it to me in degrees? 315, negative 45. Okay, I want radians, so it's... Okay, what's the angle, though? Okay, so you could tell me 7 pi over 4. You could tell me negative pi over 4. You could have also done inverse tangent, what was it? Negative 2 over 2 or 2 over negative 2, doesn't matter, it's the same thing. And it would say negative 0.786, which is just the decimal for that. All right, 3, 5. We want to, I'll say 4, but it's not 4, right? Square root of 3 squared plus 5 squared, 25 and 9, 34. Is that right? Okay, how do we find the angle back here? It's not going to be on my unit circle. Inverse tangent, 5 over 3. And it's just going to be an ugly decimal. What ugly decimal somebody get? 1.03? Oh, it says 2 in the directions. We did 2 on this one because we were just that smart. Could we do another one on this one? Well, how about, what if instead of going 1.03 this way, I went negative a whole bunch that way? How would you find that? Just think about degrees for a minute, because I know our brains don't work in radians. If this was 20, you would have had to go negative 340, right? So you would go subtract 360 to find the other way. So what are we going to do? Subtract instead of 360. Okay. So 1.03 minus 2 pi. It was inverse tangent 5/3, then minus 2 pi. Again, I did not ask on the quiz for 2 of these. I asked for 1, so you won't have to do this part. Just to make my life miserable. If it's free response, look what it says. That's kind of miserable though. We didn't do that. The directions say between 0 and 2 pi. And I expect you to give me one answer between 0 and 2 pi, okay? We would have had to do a negative here, so we would have had to move it over here. So it would have been 3 pi over 4 with a negative square root of 2 over 2. If we wanted to follow the directions, you know how good we are at following directions. Okay? And this one, same thing, we would have had to say we were going to go down here, so we would have added pi. What's 3.14 plus that, guys? 4.17, thank you. And then it would have been negative square root of 34. Okay, because they wouldn't like this. This is outside of my range of values. Yeah, we're just getting caught up in stuff I'm not going to ask you in the quiz. Okay. This one I would ask you. And it would maybe be a multiple choice question. That would be really kind of me, right? Okay, what quadrant should I be in? -3, -3. What kind of angle is that? It's a 45 for a reference angle in degrees, right? So we should be at, what's that spot on our unit circle? 5 pi over 4, yes? Okay. Is that length a 6 or a 3 square root of 2? Yeah. If we do Pythagorean theorem, it's 9 plus 9 is square root of 18, which is 3 square root of 2, not 6. Find rectangular coordinates for this point. How do you do this? Don't need to change it to radians. How do you, if you're given polar, you have an r and a theta, so you do what? Or cosine of, oops, or sine of, so at 150, cosine is negative square root of 3 over 2, and tangent is 1/2. Did I do that right? So 4 times a half means the y should be 2, and 4 divided by 2 is 2, and there's a negative square root of 3. Which is choice? Okay. All right, 9.4. Again, the learning target today is to identify polar equations of conics. What are conics? We got 2 words here, polar and conics. Conics is hyperbolas, circles, ellipses, parabolas. Okay. So this isn't as hard as it sounds, okay? Then it says write and graph. Well, that's the part that I cut off because we don't have time, okay? We are going to need the eccentricity, but We don't have to do any calculating this time. It's going to be nicer. You're going to like this. Promise. Okay? Remember, for a parabola, the eccentricity was 1 because the distance between the focus and directrix was equal. Any point on here was equal? Okay. You're supposed to know these, but actually it says you must memorize them, but they're on the sheet, aren't they? Are they again on that sheet? Okay, how about the gray sheet? Anybody have out their gray sheet? No, it's not on the gray sheet either. It's on the blue sheet. The green sheet? The one that has eccentricity on it. Okay? Okay, the one that has eccentricity on it does tell you that an ellipse is less than 1, right? A parabola is 1. A circle is 0. And a hyperbola is greater than 1. Okay? It doesn't tell you these two. These are the two you have to know. All right. This says it's on the yellow reference sheet. Is this on the yellow reference sheet? Oh, yeah. You don't need the graphs. Isn't it on there? Oh, it is on there. Okay. I thought I put eccentricity on the yellow one. It is on the yellow one, right? The little paragraph about eccentricity? Yeah. Okay. All right. Look at these equations. Tell me what you notice. Okay. They're minus and pluses. What else is different about them? There's cosine and sine. Okay. What do they all have in common? They all have E's and D's and thetas, but they all have ones. Okay? That 1 is really important. Okay? You have to have a 1 in that spot for this equation to work, because that's what it shows. So if it's not there, we're going to have to make it be a 1 in that spot. Okay? It's not as hard as it sounds. All right. The other thing I need you to notice that's really important is right up here. It says both E and D are positive numbers by definition, okay? So when there's a minus in here, it's not that E is negative, it's the minus as part of the equation. All right, the other thing that I will point out to you, you get to use this, okay? So you don't have to know this, but I will point out to you cosine has a vertical x equals, remember cosine goes with x, okay? Cosine has a vertical x equals line. And then if it's a plus in here, it's a positive D. If it's a minus, it's negative. That's the directrix, okay? Sine, guess what? Both of the sine ones are y equals. And again, the positive goes with positive, negative goes with negative. All right, now I got a weird idea for you. This makes sense for parabolas, okay? But did you know an ellipse has a directrix? We only did directrix on parabolas, right? Okay. So there's a directrix for everything. It's weird. It determines where it is on the graph when you're in polar graphing. Okay, so in this form, determine the eccentricity and use this value to identify the type of conic the equation represents, and then determine the equation of the directrix and use it to describe the orientation of the conic. I'm not going to make you do the orientation of the conic. So I'm going to ask you to look at this equation, find the eccentricity, tell me what kind of conic it has to be then, and give me the equation of the directrix. All things you can pull right off that reference sheet, okay? All right. So here we go. Here's the first example. Given this equation right here, what did I just say we had to have that isn't there? A 1. I'm going to explain it a little different than they do. I'm not going to factor anything. I'm just going to say we want this to be a 1, so I'm going to divide everything by 3. So then I will get 2 over 1 plus 1 sine theta. okay? Which is this equation. All right, if that equals this, what's E, first of all? E is all by itself as the number in front here, right? So whatever this number turns out, that's E. So if E is 1, it has to be what shape? If the eccentricity is 1, parabola, okay? And then to find D, you have to look at the top. So you know that E times D should be 2, and if E was 1, then D has to be 2 for this one. So, and it had a plus and it was a sign. So the equation is y equals 2. Okay, now you're just looking at me like, I don't get it. All right, let's try this one. It's not fun, huh? I think it's easy once you see the idea. You have the reference sheet in front of you, okay? This has to be a 1. It is currently a 1. So the formula says 1 minus E sine theta over ED, under ED, right? So what is E? It is this 1/2 right here, and it's always positive, okay? Back to the definition here, guys. E and D are always positive. If it's a minus, it comes from the equation later, okay? So E is the 1/2 that's right here. So what shape does that make it? Look on your reference sheet if you need to. What does it say? When it's less than 1, it's an ellipse. Then the third question is going to ask for the equation of the directrix. Okay? The equation of the directrix, which it doesn't feel like an ellipse should have, but the equation of the directrix is x equals or y equals, because it's sine, it's y equals, positive or negative, that comes from here as well, minus, and then we have to figure out what D is. Okay, well, it says right here ED, right? And what did that top equal? 2. And what else do we know? E is 1/2. So we have 1/2 D equals 2. How to get rid of that 1/2? Double both sides, yes. So we get D equals 4. So the equation of our directrix is y equals -4. It's just cookie cutter. It's just a recipe that you have on the reference sheet. You okay? All right. Let's try this one. What's wrong to start with? This is not a 1. Remember, that's what it has to be, a 1 right there. So what do we have to divide everything by? 2. So it's going to be R equals 4 over 2 divided by 2 over 2 minus 3 over 2 sine theta, or 2, 1 minus 3/2 sine theta. No, not y. Y eventually, but for this question, we're still going R. Okay, and that's equal to ED over 1 minus E sine theta. So you know where I'm getting all this on the reference sheet. Okay, so what's E? It's 3 over 2, and it's not ever negative, okay? E is 3/2, which makes it greater than 1, which makes it a hyperbola. And the top, E times D is 2, it says. Right up here. But we already know that E is really what? 3/2. So what does D have to be? To get rid of 3/2, you multiply by 2/3 on both sides. So we get D equals I got 4/3. I did not get 3. Yes, 4/3, right? Okay, so the equation, y or x, look at your reference sheet. When it says 1 minus sign on the bottom, it's the directrix equation is y equals negative, and then whatever d is, which is 4/3 for this question. All right, let's take a little calculator break because you're all... Let's type one of these in and see what it looks like. Okay? Go to the first one, number 1 there. You should be in parametric mode and radian mode. Polar mode. It starts with a P. I don't know. Polar mode and radians. Go to y equals and type in 2 divided by the quantity 1 minus, I'm just going to use 0.5. Is that okay? Sine of theta. Make sure that whole bottom is in parentheses. All right, I'm checking my window. 0 to 2 by 0.1. Yeah, that seems okay. That looks a lot like a circle. It's supposed to be it's supposed to be an ellipse, but ellipse is a kind of a circle anyway. And an e of 1/2 is not stretched. Did you not get this? Did someone else? Okay. Just do a zoom square maybe. If it's not showing up because your window's got something weird going on, let me know because we could reset it. Blurta, did you get it to work? Oh, really? Okay. All right, let's try the next one. It was 4 divided by, I'm just going to type the original equation in so we'll know if we made a mistake along the way here. 2 minus 3 sine theta. Okay, it's going to be weird. Do you see the what? Well, you see the asymptotes because it's a hyperbola, right? And we said to do it in connected mode. I don't know. On those calculators, I couldn't find this. If I turned on what's called dot mode and didn't do it, told it just to plot the points, you wouldn't get the asymptotes because it doesn't connect them. I don't see that on your guys' calculators, but maybe you have to turn it on in a different place on the nice colored ones, but doesn't matter. All right, it was indeed a hyperbola. Okay, so this one's a minus and a cosine. Let's play around with the calculator first, since we got it out. 3 divided by 4 minus 2 cosine this time. So it looks like an ellipse, right? We'll double check that when we do the math. I just want to get rid of all these. I wanted to see a parabola. Does this one happen to be a parabola? 8, 4 plus, it's not a parabola, is it? 3 sine theta. What would, oh, it's a big egg. Okay. If it's a parabola, the eccentricity has to be 1. So what if I just change the eccentricity on this to 1? Where's the eccentricity? Do you remember? Right, yeah, if I change that 3 in front of the sign to a 1. Oh, yeah, I have to make it a 1. Oh, I could have made it a 4, because then when I divided by 4, it would have been a 1. Did you get a parabola eventually? I got it to work. You could put 1 plus 1 sine theta. I just did 4 plus 4 sine theta, so it's possible to make it. All right, let's finish these two. Okay, how do we find E again? I need it to be a 1 down here, so I have to divide everything by 4. So this is going to be 3/4 minus 2/4 cosine of theta, which is 1/2. So the eccentricity is, okay, off your sheet, it says this. So the eccentricity is this number, and the eccentricity by definition is positive, so it's 1/2. 1/2 eccentricity makes it an ellipse, yes? And then D, the directrix, well, up top ED was equal to 3/4, but I already know that E is 2/4, or 1/2. Doesn't matter which you use. So what do I get when I divide that or multiply by reciprocal? Anybody get 3/2 or 1.5? I don't care. And you can look at your reference sheet for the equation, but I tried to kind of teach you what it is. Cosine means it's, sorry, x equals. And because there was a minus in here, it's a negative. Does anyone have that one? Let's go back and look at this one on the screen, because I'm kind of curious about where that would be. 3, and then it was down here 4 minus 2 cosine. Okay, it was a little egg one, right? Where would x equals negative 3/2 be? Can you tell? X equals is a vertical line. Looks like it would be just to the left, doesn't it, of this? Okay. I was just curious where it would be. All right. Last one, maybe, of this kind anyway. R equals, what do we got to divide everything by? 4. So the top will become 2 and 3/4. Okay. Eccentricity then is 3/4, which makes it an ellipse. And it makes the top, ED was 2, and E is 3/4. So D is 2 times 4/3, which would be 8/3. Okay, so what's the equation of the directrix? Y equals 8/3, yes. Okay. Get to use a reference sheet. So I hope this is just a plug and chug section. Once you got the hang of it, does it seem pretty easy? All right, are there a couple more questions I should look at? Eccentricity for, oh, this is even written weird, isn't it? But we'd have to divide everything by what? 16. So 48 divided by 16, 16 divided by 16, 8 divided by 16. So the eccentricity would be 1/2. Okay, same question, so we don't have to do anything more except determine the equation of the directrix. So ED is 3 up top, but this is 1/2, right? Which makes it 6, and it's cosine, so it's x equals. And what kind of conic would it be then? We had enough ellipses today, only one hyperbola. I didn't do a very good job. I shortened the worksheet, remember I said that? And I just picked some off and threw them away, and apparently I threw all the hyperbolas away. All right, so guys, the work for this, you have this. It's on 7B, okay? On the back of worksheet 7, I included all the book problems so that you could get it done. Okay. When you go to do review for the quiz, which is what we're going to do on Monday, we're going to review for the quiz because the quiz is Tuesday. We are going to do worksheet 10. Yes, that's where all the review is. And the bookwork that goes with 10, I put it on the back of the gold sheet just because I was running it anyway. So I thought, slip that in there, saving paper, okay? The back of the gold sheet has the bookwork that goes with worksheet 10. All right, so we will review Monday, quiz Tuesday. And I cannot stress enough that this would be a really good time to kick in and do a little homework because there's not going to be any automatic retake. All 4 of the things on this quiz will not appear on another quiz. You want to retake it? You got to come in on your own. This is quiz 10. We possibly will only have one more quiz, okay? We definitely have a quiz on sequences coming up. It's possible there would be a little mini quiz somewhere that had limits on it. It's also possible that it won't be on a quiz and it'll just show up on the final. I don't know that seniors are going to get to have to do limits. Might just be too late. Kind of depends how it all goes because of all the AP testing. I haven't figured out who's gone which day, and we're losing like 4 days where almost everybody will be gone. The problem is, like, the day you take an AP test for some senior class, everybody else will be here, so you'll just miss. But, like, the day that's a push, almost everybody's gone. So you and I can just sit and chat, okay? Right. Oh.
Because I feel like it's easier English, and I feel like it's easier to take the English class at the college that I'm going to. If I can get like a little more grade. I'm taking it to government.